Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Your Excellency, all the committees, Your Excellency, all the participants of the ASEAN Education Symposium 2023. Ladies and gentlemen, on these occasions, I would like to explain about one of our research collaborations entitled Development and Validations of Tests of Science Process Skills for Secondary Students on Cellular Living System Organization Matter, Rush Model Analysis. So here's are the authors. My name is Subagja, and on this research, I also with Professor Dr. Bibin Rubini MPD and Dr. Surti Kurniasi MSI, and we are under Department of Science Education, Postgraduate School, Pakuan University, Bogor, Indonesia. So, ladies and gentlemen, first I would like to explain about the background of our research. As we all know that now we are living in the 21st century age. On 21st century age, all the activity refers to the technology, internet, and all the characteristic of the 21st century age, including in educations, especially in science educations. Today's science education is critical to help students comprehend scientific ideas to mastering 21st century skill. What is the 21st century skill? On this picture, I show you that 21st century skill, we can divide it into three groups. The first one is foundational literacies, the second one competencies, and the third one character qualities. Because of the reasons, science learning today in the classroom should provide students with the opportunity to practice the 21st century skills. Then, as we all know that in Indonesia itself, we have a several change of the curriculum. The latest one that we are applying is the Merdeka curriculum. The Merdeka curriculum strongly emphasizes the accepted practices of the scientific learning methodology and shape the behavior of active learning and inquiry-based learning. For implementation, the active and inquiry-based learning, students have to achieve the science process skills. What is the science process skills? The science process skills is the complex skills, complex abilities that scientists use to conduct scientific investigations. The science process skill reflect the method used by scientists in producing complex informations about the science, such as the product, attitudes, processes, and the application of science itself. Science process skill, we can divide it into two groups. The first group is basic, and the second group is integrated. The question is there a standardized assessment for science process skill in Indonesia? Based on my literature review, some of the researchers are developed science process skill assessment, but mostly for high school, not much for students, for the secondary students and the elementary students. Because of that reasons, I decide to develop and validate the science process skill assessment for the secondary schools. The next one is the method. For the method, I'm not explicitly say that I'm using the R&D, but the steps I use refer to the R&D models. So the first stage is the preliminary stage. On the preliminary stage, the first activity is problem identifications. For the problem identification, as I said before on the background, so I find that the science process skill is one of the skill that students have to achieve today. So because of that reasons, I start to identifying the science process skill based on the literature review. The activities including the defining the definitions and then defining the indicators, and I conduct some interview with a science teacher. And then I start to choose the subject matter that I want to apply on this research. So the subject matter is cellular living system organizations matters. So the next activity examine the subject matter that are by science process skill criteria. After that, we are going to the second stage. The second stage is development stage. On the development stage, the activity are designing draft and making science process skill test items, and they revised by supervisor, then instrument initial product. And after that, we are going to validating instrument by assessment expert. Then analysis of the item and revisions. After the development stage, we are going to the final stage. On the final stage, I start to conduct the field test. On the field test, I using 30 secondary school students as my research subject. The data were collected. I analyzed with rush model analysis using the mini-step software, the analysis item including the test of difficulty, validity, and reliability. And The final product of instrument are provided when the revisions are required. Then the next set is findings. On the findings, I divide into two sections. The first section is instrument development process. On the instrument development process, the first activity are identifying the test objective and specifying the content. So I choose 9 science process skill indicator that are the observing, specifying, hypothesizing, using laboratory tools, planning experiments, applying concept, interpreting, communicating, and asking question. And also, I start to make a descriptions of the indicator. For example, from the observing indicator, the activity including using multiple sense and then collecting relevant and sufficient facts. And after that, after the identifying activity, the next stage is writing test item. On the writing test item, I developed 3 questions in one science process skill indicators because I thought about the balance in the question. So in total, I made 27 questions. So these are the example of the question that I developed. Chlorophyll pigment in chloroplast play a role in the photosynthetic process of plant. A scientist conduct research on the amounts of the chlorophyll in several types of green vegetable, whose results are presented in figure 5. So the question is the correct conclusion that can be explained on the graph is, so to answer that question, students have to know how to read the graphs, and also they have to conclude what the information that students find on the graph. So the reading a graphs and making a conclusion is one of the indicator of the science process skills. And after writing tests, the next stage is the validating by the assessment expert and then revisions. After that, we are going to the field test. On the field test, the data from the field test we are analyzed using the Rush model analysis using the mini step software. So these are several output of the Rush model analysis. The first one is item person map analysis. On this right section is item, on the left section is persons. On the item analysis, so I start to focusing on the item map analysis. So from the variable map, 3 type of item group are obtained. The first group are the item that cannot be reached by student with the highest ability, with a logit value more than 2. And then the second group, the item can be matched by all abilities of students located at logit value -2 to 2. This one. And then the third groups are the items that have difficulty less than the lowest ability of student with a logit value less than -2. This one. So based on that picture, we can see that the item number as 12, the logit value are more than 2. So this item too difficult. And then the item number 13 and 17, the logit value less than -2. So the item is too easy. But the other items are within the student's ability range. So we have to consider the item number 12, 13, and 17. Then the next output is item difficulty and validity. So we can categorize the difficulty level of the item into 4 categories. The first one is very easy. The value is less than -1, and then easy -1 to 0, and difficult 0 to 1, and very difficult more than 1. So on this picture, we can see that the item number 12 until 23, the value is more than 1. So this item is too difficult. And then, very difficult. And then the item number 4 until 8, the items is difficult. And then the item number 3 to item number 20, the item is easy. And then item number 9 to item number 17, the items are very easy. So we also have to see the infit and outfit value for the MNSQ and ZSTD value. First, can see the MNSQ value. The MNSQ value state that the question is feasible if the MNSQ value is the range 0.5 until 1.5. So we can see that the infit value of the MNSQ are all the questions are feasible. But on the outfit MNSQ, we are see that the item number 12 and the item number 5, the item number 13, the item number 17 are out from the criteria. So we have to consider it. And then for the ZSTD value, the criteria is in the range -2 until 2. So we have to see that all the items are in on the categories of the feasible based on the ZSTD value. The next one is the item reliability analysis. Based on this data, the science process skill test items has a reliability value 0.87. So this value indicates that the item questions have varying difficulty range. So the item is reliable. So here are the conclusions. The result of the analysis of the ability of the test participants show that students have varying abilities. Then the result of the analysis show that the variation in the level difficulty of the questions ranging from the very easy, difficult, very difficult questions. And the results of the item analysis show that all the question items are categorized as the empirically valid and reliable after revisions. So, ladies and gentlemen, that brings us to my last of presentations. Comments, suggestions, and then questions are welcome. Thank you. Assalamualaikum warahmatullahi wabarakatuh.